Welcome to the series of vector videos and the second part of cross products. I recommend watching the first part of the cross product video before watching this lesson. Today we will be focusing on the algebraic properties of cross products. First, cross product of a vector by itself is equal to 0, and that's because the angle between a vector and itself is 0, and sine of 0 is equal to 0. So the property that states that the cross product of two vectors is their magnitude times the magnitude of the other vector times sine theta, in this case sine of 0 equals 0, gives us this particular property. Okay, for our second property, cross product of A and B is equal to negative cross product of B and A, and the cross product of A and B and B and A have the same magnitude or length, but they do have different or opposite directions. So that's kind of what this is saying. The third property says that if you take the cross product of A by B plus C, that's same as the cross product of A and B plus cross product of A and C. And our last one says that if you take the cross product of A plus B by C plus D, then this results in cross products of A and C plus cross products of A and D plus cross products of B and C plus cross products of B and D, which is very similar to binomial expansion. All of these properties can easily be proven by taking the cross product of left-hand side and the right-hand side with their component form of the vectors and seeing that they're equal. By definition, a scalar triple product is when you take the dot product of one vector by the cross product of two other vectors. Since you're taking the dot products of two vectors, the result will be a scalar value. Now, if you take the cross product, we will get a vector. And when we have a vector, we have a direction. Let's look at that direction. We've already done this in the last video, but let's do it again because it is very important. We have vector A and B, they're being cross products, and we have to use the right hand rule. To do this, we're going to use our index finger to represent the first vector, which is A. We're going to use our middle finger to represent the second vector. In this case, it's being vector B. And our thumb will point in the direction of the resultant vector, which is the cross product of A and B. Now, the resultant vector is a vector that is perpendicular to both vectors A and B. And to figure out the direction of rotation, we point our thumb towards the direction of the resultant vector. And the way that our fingers curl is the direction of the rotation. And as we said in the last video, the cross product of vectors A and B is the magnitude of vector A multiplied by the magnitude of vector B times sine of the angle between them, multiplied by a unit vector which points towards the direction of the resultant vector. The magnitude of vector, the cross product of vectors A and B is the magnitude of A times magnitude of B multiplied by sine of the theta, and we no longer need a direction for the magnitude. If we have two parallel vectors, that means the angle between them is either 0 or 180 degrees. Since cross products of A and B is the magnitude of A times magnitude of B times sine of the angle, sine of 0 and sine of 180 are both 0, and therefore the cross product of A and B when they are parallel is equal to 0. Torque is one of the biggest application of cross product. So to find the magnitude of the torque, we use the ideas that we just discussed. So we know the equation of torque is equal to the cross product of force times displacement from the last video. So this means is the magnitude of force times magnitude of displacement times sine theta times the unit vector that shows us the direction, and that means the magnitude of torque is equal to the magnitude of force times magnitude of displacement times sine theta, and we no longer need to show a direction for the magnitude. The concepts from this video are summarized here, so if you want to pause the video and write any information down, please feel free to do so. And now we're going to look at a few examples. For the first example, we are given three vectors a, b, and c, and we want to perform a few calculations on them. First, the cross products of a and b dotted c, and then cross product of a with vectors b plus c. For the first one, we're going to take the cross product of a and b first. So we're going to write our I, j, and k components and the x, y, and z components of vectors a and b. And then we are going to use our regular method, vector I. We're going to cover the top and I column and do the cross or diagonal multiplication. So 0 minus 12, and then minus unit vector j multiplied by the diagonal multiplication. So 4 minus 9, and then the z component is positive k, unit vector k, and we get negative 8 minus 0. When we put all the numbers together, we get x component of negative 12, y component of 5, and a z component of negative 8. We now take the dot product of this vector with vector c, which is 0, 1, negative 1. So we multiply their x components, y components, and z components, and we sum them all up to get 13 as our final answer. For part b, we have vectors b and c inside brackets, so we add them all up. So we add their x components, their y components, and their z components to get 3, 5, and negative 3. We then take the cross product and we write all the information. So I, j, and k, we write the information on vector a, that's negative 2, 0, and 3, and vector b plus c, which we just found as 3, 5, negative 3. Then we'll do our regular method. So we cover up I column and we do our diagonal multiplications, and we do that for j and k, and we keep in mind that we have to go positive, negative, and positive. Once we simplify everything, we get our x component as negative 15, our y component as negative 3, and our z component as negative 10. Okay, now for our second question, we got Robo who exerts a force F on a nut at displacement given, and the displacement is from the center of the mass of the nut. And we want to determine A, the magnitude of the resultant torque, and B, the angle between the force and the displacement. We know that torque is the cross product of force and displacement, and here I made a mistake and I wrote it as dot product, but I did do the cross product on it anyway, so I did make a mistake there. But we have to take the cross product, so for force, the components are 4, 3, negative 5. For displacement, they're 10, 3, and 0, and we use the exact same procedure as we did in the previous sections to find the x, y, and the z component of the torque. So that's our first step. Once we have all the numbers down, then we can find our x, y, and z components to be 15, 50, and negative 18, and our unit is going to be Newton meters. To find the magnitude of the torque, we're going to take the root of the x component squared plus y component squared plus z component squared, and when we put everything together, we get root of 3049 Newton meter as our final answer. Now that we have the magnitude of the torque, we can use the cross product equation, saying that the magnitude is the magnitude of force times magnitude of displacement times sine of theta, and we can rearrange that for sine theta by dividing both sides by the magnitude of force and displacement. Now, we have the magnitude of the torque, but we need to find the magnitude of the force and the displacement. For these, what we're going to do is we're going to take the root of their x component squared plus y component squared plus z component squares to get the magnitude of force to be root 50 and the magnitude of the displacement to be root 109. Once we have those, we're going to plug it in, and we know that theta is the inverse sine of the equation that we had. So root 3049 divided by root 50 divided by root 109, and we get theta to be approximately 48.4 degrees to 3 significant digits. Note that since we had the components of both vectors f and d, delta d, we could have used the dot product to get the exact same value for angle to be 48.4 degrees. I have left you with 3 practice questions to try out on your own, and I will try to post the full solutions to these in a separate video as soon as I can. I hope that this video was helpful for giving you an understanding about the properties of cross products, and thank you for watching.